November 23, 1942, in the overcast skies above Stratford, Connecticut. At exactly 10 a.m., a group of local farmers and factory workers stopped what they were doing and stared upward in utter disbelief. They were used to the roar of conventional engines from the nearby Vought Sikorsky plant. But what they saw that morning defied every rule of aviation they understood. Hovering and then darting through the clouds was a flat, circular object that looked more like a giant wooden frisbee than a fighter plane. It had no fuselage as people knew it, no distinct wings, and two massive wooden propellers that seemed much too large for its body. To those on the ground, it was a terrifying glimpse into a future they couldn't comprehend. Some whispered of secret German weapons, while others simply thought they had lost their minds. In reality, they were witnessing the maiden flight of the Vought WW2, the aircraft that would forever be known as the Flying Pancake. The brainchild of engineer Charles Zimmermann, the BI-173 was the product of a radical theory that challenged the very foundation of lift. Zimmermann believed that a disc-shaped wing would eliminate the tip vortices that cause drag on traditional aircraft, allowing a plane to take off and land at incredibly low speeds while maintaining high-speed performance in combat. By 11 a.m., on that first day of testing, test pilot Boone Guyton had already realized that this bizarre machine could do things no other aircraft in the American arsenal could match. It could practically hover in a stiff breeze, and its stall speed was so low that it seemed to hang suspended in the air like a kite. As the months of testing continued through 1943, the secret project became an urban leg in the Connecticut countryside. Sightings occurred at all hours. At 2 p.m., on a clear Tuesday, a local police officer reported a flying saucer hovering over a ridge, only for it to accelerate and vanish toward the coast. These reports were often suppressed by the military, but the leg grew. The V-173 wasn't just a curiosity. It was a desperate response to the threat of the Japanese Zero and the need for a fighter that could operate from the small decks of escort carriers or even from rigged merchant ships. The Navy saw in this pancake-shaped wonder a way to bring air power to every corner of the Pacific without the need for massive, vulnerable runways. By 3:30 p.m., during one of its most intensive evaluation flights, the V-1773 proved it was nearly indestructible. Guyton had to make an emergency landing on a beach after an engine failure. Instead of flipping over as a traditional fighter would have done, the Pancake simply skidded across the sand and came to a halt, the pilot walking away without a scratch. It was this resilience and the peculiar aerodynamic properties that led the Navy to authorize a full-scale, all-metal version known as the XF-5U, or the skimmer. This new version was designed to be a beast of a machine, capable of speeds over 400 miles per hour, while still being able to slow down to a mere 20 miles per hour for landing. Yet, as the war dragged on and the calendar turned to 1945, the very innovation that made the Flying Pancake so special became its undoing. The world was changing faster than the wood and fabric of the V-173 could handle. By 4:15 p.m. on a late summer afternoon, as the first jet engines began to scream over European battlefields, the piston-driven propellers of Zimmermann's dream began to look like relics of a bygone era. The Navy eventually realized that while the skimmer was a masterpiece of mechanical engineering, the future belonged to the turbojet. The project was shuttered, and the prototypes were ordered to be destroyed, leaving only one survivor to eventually find its way into a museum. Looking back at those mysterious sightings over Connecticut, we see more than just a failed experiment or a quirky footnote in a history book. The Flying Pancake represents a moment in time when the limits of human imagination were being pushed to their absolute breaking point. It was a bridge between the era of canvas-covered biplanes and the sleek, saucer-shaped dreams of the space age. We are left to wonder how the skies might have looked if the jet engine hadn't arrived to claim the throne. Perhaps the greatest legacy of the V-173 is the reminder that in the heat of global conflict, the most absurd ideas are often the ones that bring us closest to the impossible. It stands as a testament to the engineers who were brave enough to stop looking at what a plane was and start imagining what a plane could be. leaving behind a silhouette in the clouds that still haunts the American imagination. July 1933, at the Langley Memorial Aeronautical Laboratory in Virginia, a young engineer named Charles Zimmerman began sketching a shape that would eventually terrify the residents of Connecticut and baffle the greatest minds in aviation. To Zimmerman, the traditional airplane was a flawed design, a compromise between lift and drag that relied far too heavily on long, fragile wings. He looked at the sky and saw something different. He envisioned a craft where the entire body was a wing, a perfect aerodynamic disc that could hover like a dragonfly and sprint like a hawk. This was the birth of the V-173. But the journey from a napkin sketch to a soaring reality would require Zimmerman to challenge every law of physics his peers held dear. By the late 1930s, Zimmerman had moved his vision to the Vought Aircraft Company, where his radical ideas finally found a patron in the United States Navy. The military was desperate for a fighter that could operate from the cramped pitching decks of small escort carriers, or even from the decks of standard cruisers. They needed a plane with short takeoff and landing capabilities, something that could practically jump into the air. Zimmerman promised them a machine that could fly as slowly as 20 miles per hour without stalling, and then accelerate to speeds that would leave contemporary fighters in the dust. The secret lay in two massive, slow-turning propellers located at the very tips of the disc. These propellers were designed to rotate in a direction that canceled out the wingtip vortices, essentially capturing the air that would normally escape and forcing it back over the disc to create incredible amounts of lift. The first prototype, a bright yellow wood and fabric proof of concept known as the flying pancake, was ready for its maiden voyage on a crisp morning in November 1942. At 10 a.m., at Bridgeport Airport, test pilot Boone Guyton climbed into the cockpit, looking out over a fuselage that looked more like a prehistoric creature than a modern weapon of war. As the engines roared to life, the massive propellers, stretching nearly 20 feet in diameter, began to churn the air. When Guyton pulled back on the stick, the V-1733 didn't just take off. It seemed to levitate. For the engineers watching from the tarmac, it was a moment of pure vindication. Zimmerman's math had been correct. The disc worked. However, as the V-173 continued its test flights throughout the war, it began to create a different kind of history. Because of its bizarre silhouette and its ability to hang almost motionless in the air before darting away, locals often reported seeing unidentified flying objects. In an era before the term UFO was part of the common vernacular, the flying pancake was the closest thing to an alien visitor the American public had ever seen. On one afternoon at 3 p.m., a group of farmers reported seeing a silver streak that moved in ways no plane should move, fueling rumors that the military was testing captured technology from another world. As the war progressed, Zimmerman pushed for a more powerful, combat-ready version of his design, which became the XF-5U-1, nicknamed the Skimmer. This was no longer a wooden prototype. It was a twin-engine beast built of a special material called metallite, designed to withstand the immense pressures of high-speed combat. But the Skimmer was a victim of its own complexity. The vibration issues caused by the long drive shafts connecting the engines to the outboard propellers were a nightmare to solve. By the time the Navy was ready to flight test the Skimmer in 1947, the world had changed. At 2:15 p.m. on a Tuesday in March, the Navy issued a devastating order. The project was to be canceled. The jet engine had arrived, and its promise of raw, uncomplicated speed made Zimmerman's mechanical masterpiece obsolete before it ever saw a dogfight. The Skimmer was as dramatic as its design. Because the airframe was built of the incredibly tough metallite, the wrecking ball used to scrap the prototypes actually bounced off the fuselage on the first few strikes. It was as if the plane itself was refusing to die, a final act of defiance from a machine that was too advanced for its time. Today, the legacy of Charles Zimmerman lives not in the fighters on our carrier decks, but in the spirit of the radical departure. He taught us that the sky does not have a single shape, and that the boundaries of flight are only as rigid as the imagination of the person drawing the blueprints. The flying pancake remains a haunting reminder of a fork in the road of history, a path where the skies might have been filled with discs instead of darts. leaving us to wonder what else we might have achieved if we hadn't been so quick to embrace the roar of the jet. Zimmerman's vision was a bridge to a future that never quite arrived, a testament to the beautiful, stubborn persistence of an idea that was simply too bold to be forgotten. On November 23, 1942, in Stratford, Connecticut, the engineers at Vought stood in a tense silence as they prepared to test a machine that defied every established rule of aeronautics. To any casual observer peering through the chain-link fences, the V-1733 looked less like a weapon of war and more like a hallucination made of wood and canvas. It was a golden, flattened disc, spanning 23 feet from tip to tip, perched precariously on spindly landing gear that tilted its nose toward the clouds at a staggering 22-degree angle. This was not a plane that used wings to generate lift in the traditional sense. The entire body was the wing, a radical departure from everything the world knew about flight. Charles Zimmerman, the brilliant and eccentric mind behind the design, was not interested in the sleek, needle-like silhouettes that defined the fighters of the era. He saw a fundamental flaw in traditional aviation, the wing tips. In a standard aircraft, the air pressure differences between the top and bottom of the wing create swirling vortices at the tips, which generate massive amounts of drag and waste energy. Zimmerman's radical solution was to eliminate the tips entirely by making the aircraft a circle and placing two massive 16-foot, three-bladed propellers at the very outer edges of the leading curve. These propellers were designed to rotate in the opposite direction of the natural tip vortices, effectively canceling out the drag and creating a uniform column of air over the entire surface of the disc. At 10 a.m. that morning, test pilot Boone Guyton climbed into the cockpit, which was essentially a bubble of plexiglass nestled into the leading edge of the disc. The internal skeleton of the V-1733 was a masterclass in weight management, built primarily from Sitka spruce and covered in a specialized doped fabric. Because the design was so efficient at creating lift, it did not need the heavy metal skin of its contemporaries. Powering this bizarre creation were two 80-horsepower Continental engines buried deep within the fuselage. They were connected to the outboard propellers through a complex series of shafts and gearboxes that allowed both propellers to turn even if one engine failed. It was a redundant system far ahead of its time, ensuring that the pilot would never lose control of the massive blades that occupied nearly half the aircraft's total width. As Guyton throttled up, the sheer size of the propellers created a localized windstorm. The V-1733 did not require a long, thundering takeoff roll. Because of its incredible lift-to-drag ratio and the way the props bathed the disc in high-velocity air, the flying pancake could achieve flight at a mere 15 miles per hour. In a stiff breeze, it could virtually hover, lifting straight off the ground like a modern vertical takeoff jet. This was the secret that Zimmerman had unlocked, a plane that could operate from the deck of a pitching freighter or a small jungle clearing, yet still reach speeds that would allow it to intercept enemy bombers with ease. Throughout nearly 200 test flights, the aircraft proved to be almost impossible to stall. While a traditional fighter would drop like a stone if the pilot pulled the nose up too high, the V-173 would simply settle into a gentle, controlled descent, maintaining its orientation like a falling leaf. Even legendary aviator Charles Lindbergh, who took the controls during a secret evaluation, was reportedly stunned by how easily the disc handled. He found that the unconventional physics of the circular wing allowed for maneuvers that would have torn the wings off a Mustang or a Corsair. The V-173 was more than just a technical curiosity. It was a physical manifestation of a different kind of thinking. It proved that the boundaries of science are often limited only by our willingness to look at the world from a different angle. We are left today with the image of that yellow disc shimmering in the Connecticut sun, a relic of an era where the future was still wide open and the shape of the sky was not yet decided. The flying pancake remains a tribute to the dreamers who are not afraid to be laughed at, and a reminder that somewhere in the archives of history, there are still secrets waiting to be rediscovered. These were ideas that were not necessarily wrong, but simply born into a world that was not yet ready to follow where they led, leaving us to wonder what other miracles are hidden within the blueprints we chose to set aside. May 1942, Stratford, Connecticut. The airfield at Vought witnessed a sight so bizarre it looked like a prop from a low-budget science fiction serial. It was the V-1773, a proof-of-concept aircraft that defied every conventional rule of aerodynamics. Its canvas-covered wooden frame formed a nearly perfect circle, earning it the affectionate, if slightly mocking, nickname of the Flying Pancake, while the world was embroiled in a war defined by sleek Spitfires and rugged Messerschmitts. A small team of engineers led by Charles Zimmermann believed they had found the future of naval aviation in a shape that shouldn't have been able to fly at all. The secret of this radical design lay in the massive, slow-turning propellers. Usually, wingtip vortices are an engineer's nightmare, creating massive amounts of drag and reducing lift. Zimmermann turned this problem on its head. By placing oversized propellers at the very tips of the disc-shaped wing, the rotation of the blades effectively canceled out the vortices. This didn't just reduce drag, it turned the entire body of the aircraft into one giant lifting surface. The result was a plane that could practically hover in a stiff breeze and take off at an incredibly short distance, a trait that immediately caught the attention of the United States Navy. Enter Charles Lindbergh. By the early 1940s, the Lone Eagle was no longer just a celebrity. He was a highly respected technical consultant with an uncanny eye for engineering flaws. He arrived at the Vought facility to see if this saucer was a legitimate weapon or a waste of resources during a total war. He climbed into the cockpit at 10 a.m. on a bright morning, facing a steep upward angle because of the aircraft's unique landing gear. When he throttled up, the Pancake didn't just take off. It leaped into the air with a grace that silenced the skeptics on the ground. Lindbergh found that the VMI-73 could fly at speeds as low as 20 miles per hour without stalling. For a Navy desperate to operate heavy, powerful fighters from the cramped, heaving decks of escort carriers in the middle of the Atlantic, this was a revelation. He reportedly came down from the flight deeply impressed, noting that the handling was surprisingly conventional and stable, despite the radical geometry. If Charles Lindbergh, a man who had flown everything from the Spirit of St. Lan, Louis to captured German fighters, believed in the design, the Navy knew they had something special on their hands. As the V-173 hummed over the Connecticut coastline during its test flights, it sparked a wave of what we would now call UFO sightings. Local residents, unaware of the secret military project, saw a flat, silver-yellow disc hovering and darting across the sky with unnatural agility. To the uninitiated, it was an alien visitor. To the engineers at Vought, it was the precursor to the XF-5U, the skimmer that promised to dominate the air. The transition from the wooden V-1732 to the all-metal XF-5U was meant to be the masterstroke of the program. This combat-ready version was designed to hit speeds over 450 miles per hour while retaining the ability to land at a walking pace. It was built with a specialized material called metallite, a sandwich of balsa wood between two layers of aluminum. This material was so incredibly strong that during structural testing, the airframe was virtually indestructible. Legg has it that when it came time to scrap the frames, the engineers had to use heavy-duty wrecking balls just to put a dent in the structure. But time was the one enemy the Pancake couldn't outfly. By 1947, the roar of the piston engine was being replaced by the high-pitched scream of the jet. The Navy, facing massive post-war budget cuts and the dawn of the nuclear age, saw the XF-5U as a relic of a bygone philosophy. On a quiet afternoon at 2 p.m. in March of 1947, the program was officially axed. The two completed prototypes were ordered to be destroyed, though the original wooden V-173 was thankfully spared, eventually finding its way to the Smithsonian. The story of the Flying Pancake is a poignant reminder of the what-ifs that litter the path of human progress. It was a machine that solved every problem of its era, only to arrive at the exact moment that era ended. We are left to look back at Zimmermann's saucer and wonder how different naval history might have been if the jet age had stayed its hand for just a few more years. It stands as a testament to the fact that innovation is often a matter of timing as much as talent. The Pancake didn't fail because it couldn't fly. It failed because the world changed its mind about what flying should look like. It remains a beautiful, circular ghost in the machine of history, reminding us that sometimes the most radical ideas are the ones that actually work, even if they never get the chance to truly take flight. June 25th, 1945, at the Vought plant in Stratford, Connecticut, the atmosphere was thick with a strange mixture of triumph and desperation. The engineers were no longer looking at a wooden proof of concept. They were looking at a weapon. This was the birth of the XF-5U-1, a machine so radical in its design that it looked less like an airplane and more like something pulled from the fever dreams of a science fiction novelist. While its predecessor, the V-1773, had proven that a low aspect ratio disc could fly, the Navy wanted more. They wanted a fighter that could withstand the rigors of carrier operations while delivering performance that should have been impossible for a propeller-driven aircraft. The construction of the XF-5U-1 was a marvel of mid-century metallurgy. To handle the immense stresses of its unconventional shape, Vought developed a new material called metallite. This was a sandwich of two thin sheets of aluminum bonded to a balsa wood core. It was incredibly light and extraordinarily rigid, giving the flying flapjack a structural integrity that surpassed almost anything else in the air at the time. Inside this pancake-shaped hull sat two massive Pratt & Whitney R2000 radial engines. These were not just mounted to the airframe, they were buried deep within the disc, connected by a complex system of cross shafts that allowed either engine to drive both propellers. The engineering team worked through the night, often fueled by nothing but black coffee and the pressure of a war that was rapidly changing. By 3 p.m., on a Tuesday in late 1945, the complexity of the gearbox system became the project's primary hurdle. The vibrations generated by the massive four-bladed propellers were so intense they threatened to shake the entire airframe apart before it could even leave the ground. To solve this, engineers had to design specialized dampeners, adding weight and precious months to a timeline that was already slipping. The promise of the XF-5U-1 was staggering. On paper, it had a speed range that defied logic. It was projected to have a top speed of over 450 miles per hour, yet because of its unique aerodynamic lift, it could slow down to a staggering 20 miles per hour. In theory, a pilot could practically hover the aircraft into a headwind, making carrier landings safe even in the roughest of seas. But as the Kalar turned to 1946, the urgency of the Pacific War had evaporated. The massive defense budgets that had fueled such radical experimentation began to dry up. By 9 a.m. on a cold morning in March 1947, the Navy made the decision that would haunt aviation enthusiasts for decades. The project was officially canceled. It was not because the XF-5U-1 failed its tests. In fact, the aircraft was nearly ready for its first official flight. It was simply a victim of the jet age. The Navy had seen the future in the screaming engines of the McDonnell FH-1 Phantom and the North American FJ-1 Fury. In their eyes, the era of the propeller was over, no matter how revolutionary the shape of the wing. What followed was one of the most heartbreaking moments in the history of flight. Because the XF-5U-1 was built with such cutting-edge materials and classified technology, the Navy ordered the two existing prototypes to be destroyed. When the salvage crew arrived at 1 p.m. with a massive wrecking ball, they expected the odd-looking saucer to crumble like any other aircraft. But the metallite construction was so strong that the wrecking ball simply bounced off the fuselage on the first several strikes. It took hours of sustained effort to finally break the spirit of a machine that refused to die. The story of the flying flapjack is more than just a footnote about a weird airplane. It is a reminder of the narrow corridor through which progress must travel. If the XF-5U-1 had been ready in 1943, it might have changed the course of the war in the Pacific. If it had been born a decade later, perhaps its disc-shaped lift would have been mated to a jet turbine, creating a vertical takeoff craft that would still be in service today. Instead, it exists in the quiet spaces of history. It represents the brilliance of the human mind when it refuses to be bound by the traditional shape of things. We look back at its circular silhouette and see not a failure, but a glimpse into a future that never was. It teaches us that the greatest tragedies of innovation are not the ideas that fail, but the ones that were simply too far ahead of their time to be understood by a world that had already moved on. The ghost of the skimmer remains a symbol of what happens when the courage to dream meets the cold reality of a changing era. July 1947 in Stratford, Connecticut. The sharp, rhythmic sound of a wrecking ball signaled the of one of the most ambitious chapters in the history of flight. It was nearly 1 p.m. when the heavy steel impact finally crushed the airframe of the XF-5U, a machine that had cost the United States years of development and millions of dollars. To the workers watching from the hangar doors, it was not just a prototype being destroyed. It was the physical manifestation of a future that had been canceled before it could truly begin. The flying pancake was a radical departure from everything the world understood about aerodynamics. It was a machine that looked more like a science fiction prop than a weapon of war, designed to solve the impossible problems of carrier aviation by being both incredibly slow for landing and remarkably fast for combat. By 2 p.m. on that same afternoon, the remains of the second airframe were being hauled away, effectively erasing the evidence of Charles Zimmermann's revolutionary vision. We must ask ourselves why a design so promising, so technically sound, and so close to perfection was discarded with such clinical finality. The answer lies not in the failure of the aircraft, but in a massive shift in the tectonic plates of technology. The flying pancake was the ultimate evolution of the propeller age, a pinnacle of piston-driven performance that arrived at the exact moment the world decided propellers were obsolete. The Navy, looking toward a horizon filled with the screaming engines of the first jet fighters, decided that there was no room for even a brilliant relic of the past. Throughout its testing phase, the V-173 had frequently been at the center of the first modern UFO scares. At 4:15 p.m. during a routine flight over the Long Island Sound, local residents would look up and see a shimmering circular disc hovering with a stability that defied logic. They did not see a vought prototype. They saw a visitor from another world. This confusion is perhaps the most alluring part of the skimmer's legacy. It was so far ahead of its time that the human eye, accustomed to the straight lines and long wings of the era, simply could not process what it was seeing. It was a secret weapon hidden in plain sight, a machine that proved that the standard way of doing things was merely one choice among many. The tragedy of the project is that by the time the vibrations and the massive gearboxes were finally smoothed out, the strategic landscape had changed. In the early morning hours of 1945, the requirements for a carrier fighter were based on the lessons of the Pacific War, the need for short takeoffs from small decks, and the ability to outmaneuver nimble Japanese Zeros. But by 10 a.m. on the day of the skimmer's cancellation in 1947, the Cold War had already begun to freeze the designs of the future. The jet engine offered a simplicity and a raw speed that Zimmermann's complex, interlocking drive shafts could never match, regardless of how efficient they were at low speeds. As we reflect on the enduring legacy of the flying pancake, we are forced to confront the harsh reality of innovation. Progress is not a ladder where every rung is utilized. It is a graveyard of brilliant ideas that were simply born in the wrong season. The V-07 sits today in a museum, a yellow-skinned ghost that reminds us of the possibilities that haunt the history of the Second World War. If the jet age had been delayed by only a few years, the skimmer might have become the most famous silhouette in the sky. It might have changed the way we designed every aircraft that followed, leading us down a path of circular wings and vertical capabilities decades before they became a reality. Instead, it exists in the quiet spaces of history as a symbol of the courage to dream. It teaches us that the greatest tragedies of innovation are not the ideas that fail, but the ones that were simply too far ahead of their time to be understood by a world that had already moved on. Charles Zimmermann saw a world where flight was not limited by the length of a runway or the shape of a traditional wing. His creation remains a testament to the brilliance of the human mind when it refuses to be bound by the conventional. The skimmer was a glimpse into a future that never was, a radical horizon that still challenges us to look at the sky and wonder what other impossible shapes are waiting to be discovered. It is the ultimate reminder that being right is sometimes not enough. One must also be lucky enough to be right at the exact moment the world is ready to listen. The flying pancake did not fail to fly. The world simply failed to keep up with it.